This is properties of tangents. So a tangent line intersects a circle at exactly one point. And that point is called the point of tangency. So A is the point of tangency, and line AB is tangent to circle P at point A. So if it looks like it touches more, if we were to zoom in super close, it wouldn't. A line is tangent to a circle if and only if, meaning this condition must be met, it is perpendicular to a radius drawn to the point of tangency. So going back to our diagram, this point, there has to be a radius and it has to be perpendicular. Remember that perpendicular means 90-degree angle. So it has to form a right triangle. So when we're trying to determine if a line is truly tangent, meaning it only intersects a circle at one point, then we can use the Pythagorean theorem to determine if that line truly is tangent or just appears to be so. So let's look at the first four examples. Actually, the first two examples. We're trying to determine if AB is tangent. If it's tangent, then it will be perpendicular. We just don't know if it is yet. So the way we check that is we say, okay, well, if it's perpendicular, 8 squared plus 15 squared will equal, but we don't know yet, 17 squared. So 64 plus 225 equals, and again, we don't know, 289. We add that together and we get 289 equals 289. So yes, in that case, AB is perpendicular to, is tangent to circle P because it's perpendicular to the radius of 8. So now let's look at the second example. So again, if it's perpendicular, then the right angle would be here. But we don't know if that's the case. So maybe, maybe not. So the first thing I got to do is figure out all my sides. So here's a side that's 11, and this side is 14. Those are my legs, so 11 squared plus 14 squared. And if this is perpendicular, then that would be my hypotenuse. But this is 5. So what's this piece? Well, this piece goes from the center out, and coincidentally, so does that one. So that makes this also 11. Those are both radiuses, which makes this piece 16. So if it's tangent, that would be the same as 16 squared. So that's 121 plus 196 equals 256, maybe. But then I add that and I get 317, which is not the same as 256. So no, AB is not tangent, not perpendicular. So you use the Pythagorean theorem. Just make sure that you recognize where the radiuses are so that you can carry that number forward. So now let's look at number 3. This time I'm telling you that it's tangent. I'm telling you the lines are tangent. So if they're tangent, that means I should be able to use the Pythagorean theorem to find that side. If it's tangent, the right angle is over here. That means that 7 squared plus 19 squared equals x squared. That's 410. equals x squared. So x is 20.2. That's it. We're just using the Pythagorean theorem to verify what the side is for that triangle. Let's look at number 4. So here, this is the piece that's 7. Here's x, and this is 11, and this is a radius. So that means that this radius is also 11, which makes this side 18. So x squared plus 11 squared equals 18 squared. X squared plus 121 equals 324. We subtract. X squared equals 203. X is 14.2. So just again, remembering that radiuses have to be the same, and if it looks like a radius, it probably is, and that our right angle will be between the tangent and the radius, so between the two legs and never the hypotenuse. Let's look at number 5. This one's a little tricky because my variable is on the side. So I'm going to call that another variable, and I'm going to call that y for a minute, so that I have 24 squared plus 10 squared equals y squared. So that's 676 equals y squared. So y ends up being 26. Okay, great. That's what y is. But I ask you to solve for x. Well, I know that x plus 10 equals y. And now I know that y is 26. So then x is 16. For number 6. If this is 11, this is part of my radius, then this other piece must also be 11. So this whole length is 22. So when we do this, 22 squared plus x squared equals 25 squared, because my right angle needs to be between the two legs. So x squared plus 484 equals 625. X squared is 203, 3 when I subtract. And so then I take the square root. X is 11.9. Let's look at number 7. Now this one's just a little trickier because it just looks different than the other ones we've done. This takes up more of the triangle, but ideally JK, plus I think the instructions say that each time it's called JK. That's my tangent line. So again, if this is 3.5, then this is 3.5, which makes this side 7. So 7 squared plus 6.4 squared equals x squared. Put that all in the calculator, 7 squared plus 6.4 squared, and you get 89.96 equals x squared. Take the square root, and we get that x is 9.5. So again, pay close attention to the numbers that you're given and make sure that you're checking radiuses. Every time it's been the radius that we need to carry to another part of the problem. Let's look at number 8. So this one is similar to number 5. So first of all, if this is x, then this is x. But that doesn't help me. Great, so now this is 2x. But that doesn't help me with squaring and stuff. So first, I'm going to call that y. so that I can say 7 squared plus y squared equals 25 squared. So 49 plus y squared equals 625. Y squared equals 576. Take the square root. Y is 24. Great. I asked for x. Well, right here, we said that y and 2x were the same thing. So if 2x equals y and y is 24, 2x equals 24, that means x is 12. So that's one of the properties of tangents, is that they have to be perpendicular, which allows us to use the Pythagorean theorem to find one of the sides for any triangle that we can create with that tangent. Let's look at one more. Now this one is going to require something called, it's going to look weird. This is x, right? Well, so is that. That means that this piece LK is x plus 10. So what does that look like? Because this would be my right angle, so that's my hypotenuse. So what I have is x squared plus 20 squared equals x plus 10 quantity squared. Now, do you remember that what that really means is that's actually x plus 10 times x plus 10? And last year, you learned to FOIL. So x times x is x squared. X times 10 is 10x. 10 times x is 10x. And 10 times 10 is 100. So that what I get is x squared plus 400 equals x squared plus 20x plus 100. This comes down here. So now what? I still have x squareds on both sides. That's weird. We haven't done that for a long time this year. So let's figure out how to adjust that. So the first thing we're going to do is we're going to subtract x squared from both sides. I don't like x squareds any more than you do. Oh, look, now they're gone. So I'm also going to subtract 100 from both sides, because then I have just an x here and a number here. So 300 equals 20x. X is 15. So don't let it be too freaky just because it's got an x squared in the equation. You learned how to FOIL last year. This is not new. So you can do this. There are a couple of more tangent line properties. If 2 points are tangent from the same external point, here's that point. If I draw 2 lines and both of them are tangent, meaning they are both perpendicular to the radius, then they are congruent. So this comes down to looking at the picture and the diagram and understanding, if I tell you that they're both tangent and they have the same endpoint, then you have to know that that means that they're congruent. The second property is if a polygon is circumscribed, that means drawn around a circle, then all the sides are tangent. So because it is drawn around, each one of these points, D, E, and F, are points of tangency, and all the sides are tangent. And then, because AD and AF come from the same line, that means those two pieces have to be the same. And because DB and EB have the same point, just like over here, those are congruent. And because FE and CE have the same external point, then they are congruent. Okay? So let's solve these. Assume that segments that appear to be tangent are tangent. You want to look for this kind of direction just because you saw in the first two problems that one of them looked tangent and wasn't. So you want to have somebody tell you in the directions that those lines are tangent so that you can assume these properties. So number 10 looks like the first property. They both have the same external point B, and they both appear to be tangent. That means that 5x plus 23 equals 8x minus 19. These two lines are congruent. So I'm going to subtract 8x from both sides. I'm going to subtract 23 from both sides. That gives me negative 3x equals negative 42. And when I divide, x equals 14. So look at the picture. Looks like an ice cream cone. Just remember that when you look at an ice cream cone, if the lines appear to be tangent and the directions say that they are, then you can set those two pieces equal. Now this time I'm asked to find PQ. That means that after I find x, I have to find, I have to substitute the value in. So same external point, that means that those two parts are congruent. So 14x minus 13 equals 8x plus 5. Subtracting 8x from both sides and adding 13 to both sides gives me 6x equals 18. X is 3. Great, but that's not what I asked. I asked for PQ, which is 14x minus 13. So that's 14 times 3 minus 13, which is 29. So just because I'm told that those lines are tangent, I can set those two pieces equal to each other and we can move on. All right, now let's look at SV. Now we got to do a little bit of math and such. So first of all, what we just learned is that those two lines are congruent, okay? I also know that these two lines are congruent. So let's see how to figure out what SV is, because what I'm looking for is this center line on this triangle. And I know that these are right triangles, so I'm looking for is the hypotenuse. So I'm going to have to figure out what x is so I can find one of the sides of the triangle so I can use the Pythagorean theorem. So first we start by saying 10x minus 41 equals 4x plus 7. Minus 4x from both sides, add 41 to both sides. That's 6x equals 48. X is 8. So now I'm going to say that ST is 10x minus 41. That's 10 times 8 minus 41, which is 39. Okay, so now I know that this side is 39. So now I can use the Pythagorean theorem on this triangle and find SV. So then I can say 39 squared plus 17 squared equals y squared. We're going to call this hypotenuse y. So that is, when I do it all together, 810 equals y squared. Take the square root of both sides, and that's 42.5. Sorry. Shh. All right, so now we're going to use the second property to find the perimeter of this first triangle. So let's go back and look at the property. It says that if a polygon is circumscribed around a circle, then all the sides are tangent. if it's tangent, remember, that means that this side is congruent, these two sides are congruent, and these two sides are congruent. So when we go back down here, what that means for us is that if this is 16, so is this. And if this is 9.5, so is this. And if this is 11, then so is this. So then I can just add those all together. 16 plus 16 plus 9.5 plus 9.5 plus 11 plus 11, and that equals 73. That's all it is. If it's circumscribed, then these are points of tangency, which means that all of the sides are congruent, or each corner is. Now we're going to do a quadrilateral that takes just a little bit more work. So first we're going to start with, if this is 23, then so is this. But I told you the whole thing was 37.5. So that means that this piece, after I subtract, has to be 14.5, which means this piece is 14.5. All right. And now this piece is 27.1. That means that this piece is 27.1. And if I'm going to subtract it, then that means that this piece is 52.5 minus 27.1, which is 25.4. And if this is, then so is this. Not hard, it just takes some thinking. So now, when we add all those all together, so 14.5, 14.5, 27.1, 27.1, 25.4, 25.4, 23, and 23. Let's put in 0.0 so my decimal points line up. That is 180 for my perimeter. And that is the tangent properties that we're going to talk about today.